So we are moving on to the second part of our problem, and this is our power system question. This is our power system question, and these are the steps I have already discussed. We have found up to step 3. Step 1 was our Y bus. So what I have done is I have turned this Y bus data and I have found out the values. I have converted it in this rectangular form into polar form, and in the second step we are finding out our bus data, and the bus data parameters also I have written and classified what are the types of the buses we have. And in our step 3, so this is our step 3. In our step 3, what happens is we are finding out delta P, delta Q. So slack bus we don't have to find out. For PQ bus we have to find out delta P and delta Q. So I have substituted P2 calculated value and I got my delta P2 value. Then I calculated my Q2 and I got my delta Q2 value. Okay, so next what I have to do is we were doing with our Q2 value. See, this is our I is equal to 3. We were calculating a delta P3 value. So what I used to do is I was doing the calculation, and I got the values into 2.2.1.02. I got the values minus 0.07 into, I have to multiply this 1.02 also. So that value will be, the value is 0.1995. Okay, so I am checking out my values once more. So the value is 1.05. All the values 1.02 into 28 cos 5 double bracket into 1.07. So what I am doing is so that is 1.05 into 18.5696 cos 1.9513 plus 10.2430 into cos 2.2655 plus 1.02 into 28.47 into cos minus 1:89. Okay, that's all. I'll do that much. That value is equal to minus 0.09. Okay, and into, what is the value? 1.02 into 1.02. That value will be minus 0.07644. Okay, so that value is equal to minus 0.07644. minus 0.07644 per unit. So this is the value I have got for my P3 calculated. What we have to do the next is we have to find out delta P3. Delta P3 is equal to P3 generated minus P3 load minus P3 calculated. P3 generated, we have to take our line bus data. What is 3? P3 generated is 3, isn't it? So 3 minus 0 minus 0.07644, isn't it? So what is our P3 calculated value? That is delta P3 is equal to 3.07644 per unit. This is the value for our delta P3. So we have done up to our step 3, and next we have to do for step 4. Okay, so what is step 4? In the step 4 we have to find out B dash, and we have to find out B double dash matrices. What is B dash? B dash is the imaginary part of our Y bus except slack bus, isn't it? So what is our B dash bus? So I am going to find out my B dash. B dash is equal to, I am taking my Y bus, isn't it? We have to find our Y bus. So Y bus is there, and the imaginary part of the Y bus, isn't it? Except slack bus. So we have to avoid this row and this column, and finally we have to take our B bus, isn't it? So here this 2 rows and this 2 these 4 elements will be there, and we have to take the imaginary part, isn't it? So what I am writing is, I am writing the imaginary part, that is minus 19.4071 7.8689, and this is 7.8689, and the other one is 25.11, that is a minus sign is there. This is my B dash matrix. Okay, I hope everyone is clear with our B dash matrix, because B dash is the imaginary part of this matrix for all the buses except the slack bus. So one is a slack bus, no, so I am eliminating this first column and the first row, and the remaining imaginary part I have calculated. So this is my B dash matrix, and what will be my B double dash matrix? So B double dash we are finding out for what? B double dash we are finding out for our reactive power. For reactive power we have to find out only for PQ buses. So we have to, from this B dash matrix, from the B dash we are eliminating all the PV buses, and we are getting our B double dash matrix. Okay, so B double dash, what is the PV bus here? Here 3 is the PV bus, isn't it? So PQ bus is 2, only this. What is the 3 corresponding? This 3. Third one is 311, 322, 333, no? So here this thing, isn't it? So we are neglecting these things. So corresponding to 3. So I am writing, if you have any doubt, just write like this: 2, 2, 2, 3, 3, 2, 3, 3. This is no 2, 2, 2, 3, 3, 2, 3, 3. So I have written like that, and my second bus is the only PQ bus here. So I have only one element for my B double dash matrix, that is minus 19.4071. I hope you all people understand this. This is the only thing we have to remember in our decoupled load flow analysis. Rest all thing will go with our equations. Many times students will fail to remember what is many times students will fail to take this B double dash matrix. Okay, so next what I have to do is, in my step 5, what is my step 5? I am employing the current equation, and I have to find out delta delta. What is delta delta? Delta delta is equal to minus B dash inverse into delta P by E. That is a matrix. Okay, or E or V I can write. Okay, so usually I taught you by using V now, so I am writing it as delta P by V matrix. So this is the equation for finding out delta. So what are values we have to find out for our delta? We have to check. So what is a B dash matrix? So delta is for P, no? So delta, there will be 2 values, isn't it? So because we have to find out delta P is related to delta delta. Okay, so delta P, how many delta P's we have calculated? We have found out delta P2 and delta P3. So we have to write delta delta 2 and delta delta 3. So here in this delta matrix there will be delta delta 2 and here delta delta 3. Okay, if I am considering this is my 0th iteration, or k is equal to 1. Okay, I am taking k is equal to 1 for my present iteration. K is equal to 1, and then that is equal to, that is minus B dash inverse, minus of what is B dash matrix? 19.4071, 7.8689, 7.8689 minus 25.11. Thus inverse into what is delta P by V? Here this is 2 rows 1 column, isn't it? 2 by 1 matrix. So this is 2 by 2 matrix. So this should be a 2 by 1 matrix. So delta P by V. So first one it will be delta P1 by V1 and delta P2 by V2. I hope you understood how I have written the same equation. Okay, so again I am going to do my problem. Then I am continuing with my problem and substituting that value is equal to what is minus 1. So I have to find out for my matrix equation, isn't it? What is my matrix? First equation, mode matrix, second equation, and I have to find out the inverse. Okay, shift mat dimensioning 1 2 is to 2. What is it? Minus 19.4071. 1 2 is 7.8689. 7.8689 minus 25.11. so these are the values we have. Shift mat 3 1 inverse is equal to, I got the value as minus 0.059. so shall I take my minus inside? So that is equal to 0.059, then 0.0185, 0.0185, then 0.0456, 0.0456, and the other value was 0.0185. oh, that will be same only, no, because symmetric matrix. So this is the value of minus B inverse into what is delta P1. Delta P1 value, here it is not delta P1, it is delta P2 and delta P3 V3. I repeat, here it is, this is delta P2, no? So delta P2, that is P2 is a function of delta 2. Okay, so here it is delta 2, then this should be P2. Here it is delta 3, so this should be P3. If this is P2, then this should be V2, because last day we have studied in our equation that we have solved our equations and we have found out that, see, I am taking the paper again. In that equation, delta Pi by dou delta I, we got it like this and we have changed it as delta Pi by Vi, isn't it? So here also, if I am taking, this is delta P2, then it should be V2. Then delta P3, this should be V3. And this, if it is delta 2, this should be delta P2. Please don't get confused. Okay, then what is the value of our delta P2? Okay, so this value of our delta P2, we got it as minus 4.4836 divided by V2 value is 1. Okay, so the magnitude value is 1. And what is delta P3 value? That delta P3 value we got it as 3.07644 divided by what is V3 value? V3 value is given in the question as 1.02. So it is 1.02. So this we have to find out. Okay. So 3.07644 divided by 1.02. What is that value? That will be 3.016. Some value it will be there. Okay, so what I am going to do is, next I have to multiply. So shift matrix and 1, I am taking my matrix 2 and its dimensions are 2 and 1. I'm sorry, shift mat 1 2 2 dimension 1 B11 it is minus 4.4836 and B21 it is I forgot the value, 3.07644 divided by 1.02. you will get the value. Okay, B11 B12 value we got it. And delta, then next shift mat 3, my fourth answer, into shift mat 3, 2. So the value will be 0.02886 and minus 0.054. So I am writing my values, that is 0.2088. 0.20886, no, so 89 I am taking, and the other value is minus 0.055, minus 0.05, okay, 546, like that I am taking, okay. So this is the value for delta 2 and delta 3 I have got, okay. Next, what is the value for delta E? Testing and testing. So next in the step 5 we have to find out delta V value also, isn't it? So how will I write that delta V value? That also we have to take from the equation we have, that is delta V value is equal to minus of B double dash inverse into delta Q by E. This was the equation we are having. So how many delta Q value? Only one value is there, no? So we have to find out. See here P is directly related to delta, like that delta Q is a function of the magnitude of the voltage that we have studied in our decoupled load flow analysis. So here we are finding out delta Q2 only here delta Q2 alone is there, so we have to find out delta V2 only. So I am writing out delta V2 is equal to minus B dash inverse B minus 19.4071 inverse into what is delta Q2 by E2 value, isn't it? So that is equal to minus 19.4071 inverse is equal to minus 0.515, isn't it? So how I am going to find out is that is minus of minus and minus I am taking it as plus 0.0515 into what is delta Q2 value. Delta Q2 value is minus 2.7659, minus 2.7659 divided by what is E2, the value is 1, okay. So into 2.7659 and I will got the value was minus 0.1425, okay. So that is equal to minus 0.1425 per unit. So this is the value for delta V2, okay. Next what we have to do, so we have completed our step 5 also, and next we have to complete our step 6, that is the value for next iteration. So we have to find out, so this is my kth iteration, so first iteration, or sometimes we can take it as 0 also. So I am taking k as 1. So for my next iteration value, that is k is equal to 2, then what will happen, I have to find out my delta k plus 1, isn't it? So delta 2 value, this delta 2 value matrix will be of 2 values, isn't it? Here we have already found out, no? So delta 2 of value is equal to delta 2 1 plus delta 2 of 1, and delta 3 of second iteration is equal to delta 3 of first iteration plus delta 3 of first iteration. Okay, these values we have to find before we are doing our before we are winding up our calculations. Okay, so what is the function, what is the value of delta 2? That delta 2 value was first 0, now the value is 0 plus 0.2089, isn't it? So the value will be 2 plus 0.2089 will be the value for delta 2. Okay, so this will be the value of delta 2. And one more. Okay, I won't tell you that. There is some there will be some mistakes in my problem, and you have to find out. Okay, my students, as per our last class, we are employing critical pedagogy. I know I have made one mistake, and you have to find it out. Okay, next is delta 3 value. And what is delta 3 value? That is minus 0.546. So I have to, this delta 3 value, it is 0 minus 0.546, you will get another value. Okay, so the equation will be 0.046 per unit, and here the answer will be minus 0.2089. So we will get our delta 2 and delta 3 for the next iteration. And next we have to find out the value of E2. What is E2? E2 for my second iteration is equal to E2 for my first iteration plus delta E2 for my first iteration. That value E2 for first iteration, I assumed it as 1, plus what is delta E2? So it will be minus 0.1425 per unit. So that is equal to 0.8574, isn't it? So E2 value is 0.8574 per unit. Okay, so these are the values for my next iteration, and what I have to do is I have to employ these values, and I have to find out delta P2, delta Q2, and delta P3 again, and we have to find out the next, we have to continue with our step 4. No, sorry, we have to continue with we have to do with our step 3, that is employing these values. We have to find out delta P2, delta Q2, delta P3. Then this value won't change, so then we will go to the step 5, and we will find out delta E. Next we will find out the value for next iteration, and we will check the values for consecutive iterations for this power mismatch, and if the value is less than or equal to 10 raised to minus 3, then we can stop our iterations. I hope all of you understood how we can do our fast decoupled load flow analysis, and it is much easier than all other methods of load flow analysis than our Gauss load flow analysis, Gauss-Seidel, Newton-Raphson, and decoupled. Okay, thank you. Happy learning.